All right, guys, we're going to take a look at worksheet number 18, questions 1 and 2. Number 1 says a 12 centimeter tall object is placed 15 centimeters in front of a converging lens. We're going to circle converging lens, although whenever we see the word converging, we're okay, really, because it's converging, diverging, positive, negative focal length that we have to worry about. And if it's converging, then we know it's a positive focal length. And if we forget to address that, then we're going to get it right anyways, because if we forget, it's going to automatically be positive. Just as a matter of habit, though, I want to draw attention to that so that when we get a diverging one like we do in the next question, we don't forget to draw attention to it. So it is a converging lens of focal length 10 centimeters. We want to find the image distance, the image height, the magnification, and then the attributes or the characteristics of the image. A 12 centimeter tall object, that would be HO. It's placed 15 centimeters in front of the lens, that would be DO. And both of these are positive. We have to assume that the object is upright. It doesn't say so, but we will assume that. The object distance is always positive for us because it's always a real object for us. The focal length is 10 centimeters. It is a converging lens, so we know that it is a positive focal length. We want to determine DI, the image distance. We want to determine the image height, HI, the magnification, and then, of course, the attributes. So we have 3 givens to us. We want to find 3 variables, which usually doesn't work out very well for us. Okay, 3 givens, 3 unknowns. This time it's going to work out just fine for us. We have 2 equations, and we might as well start with the lens equation. Odds are if we have 3 unknowns, we're going to end up having to use both equations, although probably separate from one another here. We're going to say 1 over the focal length, 10.0 centimeters. I was chatting with somebody as you guys were working on these questions a few minutes ago. For me, I like to plug in the numbers before I rearrange this equation. There's no real good reason why you have to do that. It just works better for me. If you find rearranging it first works better for you, that's great. Go ahead and do it that way. But for me, if you're not sure, and you want to just kind of follow what I do, I like to plug in my numbers first and then rearrange. 1 over 10 is equal to 1 over 15 plus 1 over DI. And we know that we could find a common denominator here and solve it that way, the old-fashioned fraction way. But we also know there's a little cheat on our calculator that we're allowed to use here, I guess, which makes it not a cheat if we're allowed to use it. We're going to say 10x to the minus 1, so 1 over 10. We're going to take the 1 over 15 over by subtracting. So 1 over 10 minus 1 over 15, press equals. That equals 1 over DI. We're going to flip that over to get DI, and when we do, we get a value of 30. And that's a positive value, 30 centimeters. That tells us right now that we have what type of image. Positive DI means, Miles, what kind of image is that if it's a positive DI, positive 30? Good, that's a real image, right? It doesn't tell us anything about right side up, upside down. It just tells us real or virtual. A positive DI, real, a negative DI, virtual. We could get, even with a positive focal length, we could get a negative DI. Positive focal length means real focal point or converging lens, but a positive DI means real image. All right. Okay, what's next here? We want to find HI. So let's say HI over HO equals negative DI over DO. That's my other equation, or at least part of my other equation. HI is what I'm looking for here. HO I have is 12.0 centimeters. DI is 30. And DO is, what is DO? 15. So we're going to get HI here. What's that going to be? 24 centimeters? Negative 24 centimeters? My image height is neg 24. So we know that it's real already, and that's based on my positive DI. What does this tell us? Negative 24 tells us what? It's upside down. It's flipped over. Inverted, upside down, whatever you want to call it, all means the same thing. And finally, we want to find the magnification. We're going to say M. Well, we could say, since we have HI and HO and DI and DO, we could use either one, HI over HO or negative DI over DO. Let's use the first one here, HI over HO. Seems a little bit more intuitive. HI is negative 24 centimeters. HO is 12 centimeters. We're going to get a value here of negative 2.0. What are the units that go along with the magnification? There are none, right? There are none. So there we go. What does that tell us? A magnification of negative 2. No, not at all. No, exactly the opposite. Sorry? It's larger, right? The negative doesn't tell us it's smaller. The negative tells us it's flipped over. Although we already knew that, right? From the negative DI, sorry, from the negative HI. Okay, the negative tells us it's flipped over. The 2 tells us it's larger. If we get a magnification of 1, that means same size. Anything between 0 and 1 tells us it's smaller. Anything above 1 tells us it's larger. So if I get a magnification of 0.25, we get a smaller image. 0.75, smaller image. 0.5, smaller or half the size of the object. Magnification of 1.5, bigger. Magnification of 2, bigger. Magnification of 17, bigger. What if it was 1? Then that would mean it's the same size. Okay, and the same size, occurs if you think back to your array diagrams, or because you haven't drawn them nearly as much as I have, you may have to actually redraw them to think back. Okay, you might not have them in your heads, that's okay. But if you think back to your array diagrams, if I put my object at twice the focal length, 2f, on a converging lens, then we would get an image that is upside down and same size. So that would give me a magnification of -1 in that case. You'll never actually get a magnification of +1. It's impossible. Okay, you can't get an upright image that is the same size. The only time you can get same size is when it's upside down and at a very specific spot. Okay, we good there? That's the kind of question you're going to see on tomorrow's quiz. Okay, I'm telling you right now. Okay, that question that we had on our practice question set yesterday, question number 1, that was harder than you're going to see tomorrow. Question number 2 yesterday, fair game. Okay, this is absolutely fair game as well. Let's take a look at question number 2 here now, and then we'll move on to our new stuff. This one says a 12 centimeter tall object is placed, 15 centimeters in front of a diverging lens. Okay, this is really important to circle here, diverging, because that tells us that the focal length is negative. Okay, if we forget to make that negative, then everything is wrong. We could have missed that in the first question because by default it was going to be positive. But here we've got to consciously make it negative. We want to find the same things here. So we're going to say HO, is 12.0 centimeters. We're going to say DO is 15 centimeters. We're going to say F is -10 centimeters. We want to find DI. We want to find HI. And we want to find M. And along with those, we want to find the attributes or the characteristics. So because we're looking for 3 variables, we're probably going to end up using both equations again. And the one I usually start with is this one, the thin lens equation. 1 over F is equal to 1 over DO plus 1 over DI. 1 over -10 equals 1 over 15 plus 1 over DI. Let's solve for DI here. Okay, now the last question, it was 1 over 10 minus 1 over 15. This time it's 1 over -10. 1 over -10 minus 1 over 15. We flip that over, and look what we get. Okay, -6 instead of 30, like we got in the last one. 2 completely different numbers here. All right, what does that tell us about the image? Miles, what does that tell us about the image, the fact that we get a negative DI? Good, it's a virtual image. There's negatives and positives that go with all these variables. They all tell me something. This negative goes along with DI, tells me that it's a virtual image. Now, let's solve for HI now. HI over HO equals -DI over DO. HI is what we're looking for here, 12.0 centimeters. we're going to say DI is 6.0 centimeters, DO is 15 centimeters. Is that correct? Good. So Rose, what's wrong? Good. Negative 6 centimeters, right? It's negative DI, and DI is already negative 6, so it ends up becoming positive, right? So we're going to say 6 divided by 15. That gives me the right-hand side. Let's multiply that by 12. We end up getting a value for HI of 4.8 centimeters. The fact that that's a positive HI, what does that tell me? What does that tell me about the attributes or the characteristics of positive HI? Yeah, cool. Good. It's upright. It's right side up. It's whatever you want to call it that means the same thing. And finally, the magnification. The magnification is HI over HO, which is, what do I got here? 4.8 centimeters divided by 12 centimeters. We get a value there of 0.40. No units to go along with that, right? It's a positive value, which once again kind of just reiterates or redundantly tells me that it's right side up. The fact that it's 0.40 tells me that the image is smaller. Now, we could have already figured that out by looking at the image height. The image height was 4.8. The object height was 12. Of course, it's smaller. We didn't really need the magnification to tell me that, but it's as good as any way to tell me, right? Between 0 and 1, smaller. Above 1, it's going to be bigger.